Hello everyone, welcome to Equal To, and this is episode 13 of our Polynomials playlist, and here we are going to solve exercise 2.3. Okay, so let me just read the first question out for you. So here goes the first question. Determine which of the following polynomials has x plus 1 as a factor. Okay, and we have 4 subdivisions in this question. Let us start with the first subdivisions. Okay, so which of the following polynomials has x plus 1 as a factor? Okay, now there is something called factor theorem which we have been talking about in the past few episodes. So what does that say? It says that if x plus 1 that we have here, if this is a factor, then p of minus 1 is equal to 0. Right, so this is what they basically say in factor theorem, and we are going to use that concept to solve this question. Okay, I'm just moving this aside. Okay, so p of x plus 1, they want you to check if x plus 1 is a factor. Okay, so if x plus 1 were to be a factor, then p of minus 1 should be 0, right? So that is exactly what you're going to find here. So minus 1 cube plus minus 1 squared plus minus 1 plus 1. Okay, so minus 1 cube is minus 1 and minus 1 squared is plus 1, and here we have a minus 1 and a plus 1. Okay, so minus 1 plus 1 minus 1 plus 1, so this basically comes out to 0. Since p of minus 1 is equal to 0, x minus 1 is in fact a factor of p of x. Okay, here this is p of x, right? For this subdivision, that is p of x. Now that is all for that subdivision. So we have concluded that x minus 1 is in fact a factor of that polynomial. Okay, now we are going to do the same for the other subdivisions as well. Here we have a second subdivision. I'm just moving this aside. Okay, the same process goes here again. P of minus 1. Okay, so minus 1 power 4, sorry, why did I write 2? Minus 1 power 4 plus minus 1 power 3 plus minus 1 squared plus minus 1 plus 1. Right, minus 1 power 4 is 1 and minus 1 cube is minus 1 and minus 1 squared is plus 1, and then we have a minus 1 and plus 1. Okay, so 1 and minus 1, these things gets cancelled. This plus 1 and this minus 1 gets cancelled. So that gives you 1. Okay, so x plus 1 is not a factor. Is not a factor for this polynomial. Okay, sorry, I think I have written x minus 1 here. It should be x plus 1. Okay, so x plus 1 is not a factor for this polynomial. Okay, so that is it for subdivision 2. So basically it just means that if you are given something in the form of x minus a, okay, so this is basically factor theorem. We have solved multiple example questions with the same logic, so there is nothing new here. If something were to be of the form x minus a, then p of a should be 0. So that is what basically factor theorem says. Okay, now we are moving to the third subdivision here, which is x power 4 plus 3x cube plus 3x squared plus x plus 1. Okay, quite a lot of terms. So basically the same process is going to get repeated. P of minus 1, that is what you are going to find out. So minus 1 power 4 plus 3 into minus 1 cube plus 3 into minus 1 squared plus minus 1 plus 1. Okay, so minus 1 power 4 is 1 plus 3 into minus 1 cube is minus 1, and again plus 3 into minus 1 squared is plus 1, and we have minus 1 and plus 1. So 1 minus 3 plus 3 minus 1 plus 1. So this minus 3 and plus 3 gets cancelled. This 1 and minus 1 get cancelled, and that gives you 1. Okay, so x plus 1 is not a factor for this polynomial. Okay, x plus 1 is not a factor for this polynomial. So the basic process is just going to get repeated. There is nothing new or innovative here. Okay, moving on to the last subdivision of this question. So again the same process, p of minus 1, so that is equal to minus 1 cube minus 1 squared minus 2 plus root 2 into minus 1 plus root 2. Okay, so minus 1 cube is minus 1, minus 1 squared is plus 1, but we have negative sign outside, so that comes out to minus 1 as well. And then we have minus of 2 plus root 2 into minus 1 plus root 2. So let me just simplify the term again. So minus 1 and minus 1, that comes to minus 2. And this we have a minus here, let that be there. Let us just multiply this minus 1 inside, so that gives you minus 2 minus root 2 plus root 2. Okay, so that is equal to minus 2 into this minus, when it goes inside it becomes plus 2 and plus root 2, and we have a plus root 2 here. Okay, so 2 and minus 2 gets cancelled, so this gives you 2 root 2. Since 2 root 2 is not equal to 0, x plus 1 is not a factor for this as well. Let me just check this again. So minus 1 cube is going to give you minus 1, minus 1 squared is plus 1, and that turns out to minus 1 because of this minus that we have here. And then we have minus 1 here, so that basically means when it's multiplied with this minus, it becomes plus 1. So it is 2 plus root 2, and we have a plus root 2 again at the end, so that comes out to 2 root 2. Okay, so x plus 1 is not a factor for this polynomial as well. Okay, so that is it for this first question. We have given x plus 1, and with that, with using factor theorem, you can tell that p of minus 1, if it is equal to 0, then it is a factor. Now these three polynomials are not factors, and the first one is. Okay, so that is all for this question. Now moving on to the next question of this exercise, which is use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Okay, so how many cases do we have? We have 3 cases, right? We have 3 subdivision, and you are going to find the same thing basically. Okay, instead of x minus 2, x plus 1 given deliberately for all polynomials, we have been given separate polynomials, separate g of x for p of x. Okay, now the same thing you are going to use, you are going to apply what is we call as factor theorem. Okay, basically you are going to apply that to solve this as well. Okay, if g of x were to be a factor, then p of minus 1 should be 0, right? That is what you are going to check. P of minus 1 is equal to 2 into minus 1 cube plus minus 1 squared minus 2 into minus 1 minus 1. Okay, so 2 into minus 1 cube is minus 1 plus minus 1 squared is plus 1, and here we have minus 2 into minus 1, so that gives you plus 1 as well, and we have a minus 1 outside, and this 2 into minus 1 becomes minus 2 plus 1 plus 2 minus 1, so that comes out to 0, right? Okay, so you can say x plus 1 is a factor of p of x, or g of x is a factor of p of x, anything is fine. Okay, so that is it for this subdivision. So the same process is going to happen here as well. Moving on to the next subdivision here, p of x is equal to x cube plus 3x squared plus 3x plus 1, and g of x is equal to x plus 2. Okay, again by using factor theorem, you can tell that if g of x were to be a factor of p of x, then p of minus 2 should be 0. Okay, let us find p of minus 2 first. P of minus 2 is equal to minus 2 cube plus 3 into minus 2 squared plus 3 into minus 2 plus 1. Okay, minus 2 cube is minus 8 plus 3 into minus 2 squared is plus 4 plus 3 into minus 2 plus 1. So that is equal to minus 2 plus 12. This is minus 6 and it's a plus 1. Okay, so minus 8 plus 12, that gives you plus 4, and we have minus 6 plus 1. 4 minus 6 is minus 2. Minus 2 plus 1 is equal to minus 1, which is not equal to 0. So g of x is not a factor of p of x. Okay, done. The process is very similar. It's the same process basically, right? Okay, moving on to the next subdivision of this question. P of x is equal to x cube minus 4x squared plus x plus 6, and g of x is equal to x minus 3. Again, by using factor theorem, if g of x were to be a factor of p of x, then p of 3 should be 0. Okay, so basically if x minus a is a factor, then p of a is equal to 0. Okay, here in the place of minus a, you have minus 3. So a is equal to 3. So p of a should be 0. P of 3 should be 0. So that is 3 cube minus 4 into 3 squared plus 3 plus 6. Okay, 3 cube is 27 minus 4 into 3 square, that is 9, plus 3 plus 6. 27 minus 9 times 3 is 27, 9 times 4 is 36, plus 3 plus 9 is plus 3 plus 6 is 9, and 27 plus 9 is 36, and 36 minus 36 is equal to 0. So p of 3 here is 0, and you can say that g of x is a factor of p of x. Okay. Okay then, so we have solved 3 subdivisions in the second question. So with that, the second question gets over as well. So I have solved 2 questions in this video, and the approach for both these questions are the same basically. Okay, we are just using factor theorem, and we are seeing if these polynomials are the factors of the other polynomials that are given in the question. Okay, so that is basically it. If you have any doubts or any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.